Dear students, in this session, I will explain the biasing and the DC load line. For all electrical and electronic circuit to work, they need energy. Thus, energy is supplied by a DC power supply. Bias means supplying energy by DC voltage to electrical or electronic circuits for proper work. That means biasing means energizing by a DC power supply for electrical and electronic circuits to work. The bias provides suitable voltage and current for the circuit to work properly. The biasing is usually applied to an amplifier circuit. The transistor amplifier circuit will amplify, that means strengthen the small signal, AC signal applied to its input. For faithful amplification, the transistor amplifier circuits needs suitable bias. The biasing of a transistor provides forward voltage to the input and reverse voltage to the output so that transistor produces faithful amplification. Next, the DC load line. The DC load line is a straight line passing through the output characteristics of transistor in the saturation region and cuts y-axis for maximum current and x-axis for minimum voltage. Consider the circuit where VCC equals DC power supply, RC equals collector resistance, IC equals VCC equals DC power supply, IC collector current, RC collector resistance, and VCE is the collector emitter voltage. We have VCC equals VC plus VCE. You know VCC equals IC into RC. Therefore, IC into RC plus VCE. IC RC equals VCC minus VCE. Say this is equation 1. And IC equals VCC by RC minus VCE by RC. Therefore, I equals VCC divided by RC plus of minus 1 by RC into VCE. This is in the form of y equals to mx plus c, where slope equals m equals 1 by RC, y equals IC, x equals VCE. When VCE equals to 0, IC into RC, that's equals VCC from equation 1. Or IC equals VCC divided by RC, that's equals to B point. When IC equals to 0, VCE equals VCC, that's equals to A from equation 1. This is the output characteristics of and DC load line. X-axis is VCE, y-axis is IC, the point A, the point B, That means the straight line passing through A and B in the saturation region, A and B in the saturation region is called DC load line. So this is the DC load line. Next, operating point or we can or quiescent point. The operating point Q is the point intersection of DC load line and the saturation region of output characteristics of a transistor. The operating point will select the value of collector emitter voltage VCE, and the collector current IC for proper bias of a transistor. Next is the thermal runaway. The self-distortion of an unstabilized transistor is known as thermal runaway. To avoid this problem, the operating point must be stabilized. That means the zero signal values of collector current and VCE kept constant. That means